e to the, so x squared e to the negative 2x cubed. Let's go to whiteboard. So basically, let's remember this. So dx of e to the x. Remember that equals to e to the x, right? So when we take derivative of e to the x, that's just e to the x. Now let's think. When we take a derivative of e to the power, let's see, x squared. That would be difficult to write in that way. E to the power of 2x. Let's put this way. E to the power of 2x, what's that? That would be e to the 2x times the derivative of 2x, which is 2, right? So we got 2e to the power of 2x. This makes sense to us, right? Because we know how to take derivative of e term. So when we anti-differentiate, right? So when we anti-differentiate this, let's just put on that side. We're talking about an indefinite integral, so we don't care about the lower limit, upper limit for now. So when we anti-differentiate e to the x dx, and we would get e to the x, right? Now, if I change this a little bit, let me change the color. If I have this exponent is 2x, this is a 2x, right? Look at this, e to the 2x. So first, when I anti-differentiate e to the 2x, I must have e to the 2x. But when I take a derivative, that introduce a 2 here. So I have to offset it with this 2. So I get a half of e to the 2x plus c. Or you could use u substitution. Right? Let's use u substitution. We say let u be 2x. Then du equals to 2dx, right? Or dx equals to half of du. Then when we substitute, so dx, we substitute with half du, dx with half of du, so right, half of du. And e to the 2x would be e to the u. Right. You see where does this half come from? So when we anti-differentiate e to the u, that's just e to the u, right? Then you substitute u back to 2x, that's e to the 2x. But I would have to carry this half. So we get a half of e to the 2x plus c. Now the exercise is this one. It's x squared e to the negative 2x cubed dx. Well, let's use u substitution. You see, okay, let u be negative 2x cubed. Then du equals to negative 6x squared, right? That means we can rewrite dx, right? That means x squared dx equals to negative 1 over 6 du. Right, with this, we can substitute. So x squared dx, we can substitute into 1 over 6 du, negative 1 over 6. Right, we'll put it in front of the integration sign, du. And then e to the negative 2x cubed becomes e to the u. So now you see the pattern, right? When we anti-differentiate e term, we just set the exponent of e to be u. So when we integrate, we get negative 1 over 6 e to the u. Well, u is negative 2x cubed, right? Negative 2x cubed plus c. For infinite integral, because we have no lower limit, upper limit, it's called indefinite integral. With indefinite integral, we get a bunch of family, we get a family of functions. The function depends on the constant c. So we just add c to it. Sometimes we're given an initial point. When we're given an initial point, we will be able to find a specific c. Okay, anyone has any questions for this? All right, so to deal with this, just set the exponent of e to be u. Okay, let's go back to the book. Questions? What about the first x squared? What about the first x squared? X squared is the derivative part, right? Do you see here? Let me change the color to be red. You see x squared and the dx is right here. X squared dx. Okay, does it make sense? Okay. All right. Yeah. X squared is part of the derivative. Okay, good. Yeah, always make sure to ask questions. Okay. Let's see this one, square root of an exponential function. So we want to find the antiderivative of the exponential function e to the x outside, and also we see 1 plus e to the x and the square root sign. So how do we deal with this? So e to the x and the square root of 1 plus e to the x can be written as 1 plus e to the x raised by half. Now we use u to substitute 1 plus e to the x. Okay, so this one is a little bit different, right? Because this one we have a product of two functions. You see, we have a product of two functions, both with e to the x. So we let u be the 1 plus e to the x. Then how do we write e to the x? That is u minus 1, right? So e to the x is just u minus 1. So u minus 1 times the square root of u. Excuse me. So, okay, so let u be 1 plus e to the x. So, why they read twice? Okay, anyway. Then du equals to, of course, e to the x dx, right? So we can rewrite u, we can rewrite as u raised by half, because 1 plus e to the x. Hold on, I think this has some typo in it. So u equals, no, e to the x equals to u minus 1. So we would get u minus 1 times u raised by half. Okay, this has a little typo. Let's go to the whiteboard. So the integrand is e to the x and square root of 1 plus e to the x. Or we just write it, 1 plus e to the x raised by half. And we see the trouble is 1 plus e to the x, square root of 1 plus e to the x, right? We use u to substitute the trouble part. So we said, okay, let u be 1 plus e to the x, e raised by x. Then we can rewrite e raised by x equals to u minus 1, right? Because the outside we have e raised by x. So we have to be able to substitute that one into u term too. So we let u be 1 plus e raised by x, then e to the e raised by x, we can write as u minus 1. So now, okay, so du, so we need to figure out du. Once we use u, we set up u, figure out du. Du is just e to the x dx. Is in the outside e to the x covered by the du? Oh, you're right. You're right. You're right. Thank you. Thank you. Right, you're right. The book doesn't have any typos. Yeah, I was thinking too much. Yes, that's just the du part. Yes, but sometimes I was thinking, I thought more. Sometimes we need to do that, but in this case, we don't need to do that. Thank you. Good point. Paul, thank you. Let's go back to the book. Yeah, the book doesn't have typo. I made a mistake. Yeah, it's my typo. Exactly right. I just hate, I cannot write on this. So e to the x and dx is the du part. Is the du part. Because also they write u equals 1 plus e to the x twice. I thought maybe they want to write e to the x equals u minus 1. Yes, so e to the x dx is just the du part. Yeah, exactly right. So e to the x dx, that's the du. So then we can rewrite this as u raised by square root of u, or u raised by half. Then by power rule, we get a u raised by 3/2 divided by 3/2 plus c. Then we change u back to be 1 plus e to the x. Dividing by 3/2 is same as multiply 2/3 to get 2/3 of 1 plus e to the x raised by 3/2 plus c. Great. Great. Thank you, Paul. Anyone has any questions for this? All right, let's keep going. Let's see this one. Well, this one, of course, we're going to let u be, actually, you know what? You try. You guys try 1.32. So my hint is let u be 3 e to the x minus 2. So I'll do here too. So I'll do this. So we get the u squared. We just have offset by 1/3. Okay, you may type your answer in the chat to see if we have the same answer. Missing one. Delete this. What do you get? Over 9. Okay, let me take attendance also. What about the rest of you? Okay, Ali has 3e to the x minus 2 raised by 3 divided by 9 plus c. 1 over 9. 1 over 9 plus c. Why 1 over 9? I get a 1 over 3. Yeah. Okay, Paul has 1 over 3. Oh, times another 1/3. Okay, let's go to the whiteboard. So what we have here, yeah. Let's see why we have a 1 over 9. So we have e to the x, 3x minus 2, square dx, right? We said let u be 3e to the x. I'm missing e here. You're multiplying the constant with the power and then dividing. Okay, so I'm making a mistake. So this is a 3e to the x, all right, e raised by x. So let u be 3e raised by x minus 2, right? Then du equals to 3e to the x, isn't it? dx. Then e to the x dx, oops, equals to 1/3 of du, right? Or 1/3 of du equals that. Let me know if I made, did anything wrong here. All right, so e to the x dx is 1/3 of du, right? So 1/3 of this and du. And then the rest just becomes, so this guy 3e to the x minus 2, that's u. Why write e here? That's u, right? U raised by square. So that's u squared. So anti-differentiate this. We got 1/3. Oh, okay. Yes, we have twice 1/3. U raised by 3 divided by 3 plus c. Yes. I made a mistake here. I didn't do this divided by 1/3, divided by 3. Okay, so easy to make mistakes. So 1 over 9 u cubed plus 3. Thank you. I mean, u, we can substitute u back, right? This is 3e to the x minus 2. 3e to the x minus 2 raised by 3. Great job, guys. Anyone has any questions? Good job, guys. I am proud of you guys. All right, so let's go back. I think you guys are smarter than me. Day by now, I'm feeling very tired. You guys are still very energetic. Okay, all right. Okay, let's see this one. This one, by the chain rules, we let u be 2x cubed. Oh, let me show the solution. So we let u be 2x cubed, so the exponent of e term. then du equals 6x squared dx. But we only have 3x squared dx. So 3x squared dx will be half of du, right? So it will be half of du. So just write half of e to the u du, right? So just half of e to the 2x cubed plus c. All right, so it's very, very similar. So this will be same thing. E to the u, let u be x raised by 4. So du would be 4x cubed du. Then see, we only have 4x cubed du equals to 4x cubed dx. But we only have 2x cubed dx. So we substitute this into half of du. All right. Let's see this one. Now this one is a definite integral. So we have lower limit 1, upper limit 2. And the exponent of e is 1 minus x. Here we'll do the same thing. Let u be 1 minus x. So du will be negative dx. Or dx will be negative du. We substitute, we get the e to the u, negative sign put up front. Then we anti-differentiate. It's just e to the u itself. Then we change u to be 1 minus x. So it's just e to, so negative e to the 1 minus x. But here they change the limits. They were saying, okay, at 1, when x equals 1, just plug into the equation u equals 1 minus x. If x is 1, 1 minus 1, u will be 0. Right? If x is 2, 1 minus 2, that would be negative 1. So we could change the limit, but we don't really have to because we can always substitute back. So let's follow that, follow the book. So x equals 1, change it to be u equals 0. X equals 2, change it to be u equals negative 1. So we evaluate anti-differentiate e to the u, just e to the u. We evaluate at 0 at a negative 1. So we get e to the 0 minus e to the negative 1. Right? E to the 0 is just 1. Right? Just 1 minus 1 over e. 1 minus 1 over e, or 1 minus e to the negative 1. Anyone has any questions? Okay, I'll just keep moving, all right, if you don't have any questions. So that means we're finding, so we have this function e to the 1 minus x. That's our integrand. Okay, we want to evaluate the definite integral is evaluating the area, finding out the area between 1 and 2 under this function. Okay, let's try to find the area of this one, 1.34. So let's all try it, then we compare our answers. Okay, let's see, we have the same thing. Okay, Alexander, Damon, Raw, Damon, Golan, Ali, Paul, Alexis, Zanib. Let me see. So I have Alejandro here, Li Zhen, and I have Alexander Borostos. Your last name start with B. I have Darren May. I I have Fu Junpan, I have James Kwong, I have Kelly Chong, I have Nuzet Kang, I have Shihaya Alta. I'm not able to see your name right. I have Woodley. Okay, I'm hoping all of you participates. Okay, I'm hoping, you know, take attendance, take pictures, take attendance who are here, and also I'd like you to you know, when I ask you questions, I'd like you to participate. All right, like, you know, I want you to do 1.34. I'd like you to show me your answers. Hopefully, I have 17 of you here. Hope I got 17 answers. Hopefully, ideally, the 17 answers are the same. Okay, that's what I'm hoping for. It's okay to make mistakes, right? But I just want you to show your full participation. And also I want you to show, you know, you do understand what I was talking about. All right, try to, oh, Zachariah, okay, good. I didn't, so that means someone left. Right, so because mine, interesting, mine have 18, but I don't have a Zach. Oh, I missed, so the picture was missing you probably. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Oh, okay, I didn't take a good picture. Let me take another picture. Okay, so please try, you know, I'll try to participate. Okay, so let's see. So I got half of, when I see something off, sometimes I mean parentheses. Okay, so half of e to the 4 minus 1. Half of e to the 4 minus 1. Half of, yeah, okay, by e to the 4 minus 1, half of e to the 4 minus 1. Okay, so e to the 4 divided by 2 minus half, that's the same thing. Okay, good. Okay, I have how many people? I have 1, 2, 3, 4, 5, 6. Okay. 26 point something. Go on, we don't want to get, we want to get exact answers. Okay, we don't want to estimate. Like half of means parentheses, half of e to the 4 minus 1 is perfect. All right, good. Let's keep moving. So no one has questions, huh? Good. Okay, good. Wait, what is in minus 1? Wait, why is it minus 1? Oh, I mean this. I mean half of half. When I say off, I mean this. I mean I have parentheses, e to the x minus 1. So this is what I mean. You could write e to the 2x, of course. I mean e to the 4. E to the 4, not e to the x. E to the 4. So the answer is e half of e to the 4th power minus 1. So that's what I mean. Okay, I think we all have the same answers. Okay, if anyone has any questions, feel free to jump in. Okay, so usually we use growth of bacteria. Was okay. Let's see. Suppose the rate of growth bacteria in a Petri dish is given by Q of t equals 3 raised by t exponential function, right? Where t is given in hours and the Q of t is given thousands of bacteria per hour. If a culture starts with 10,000 bacteria, find a function potential Q of t. So basically, the capital letter Q, we mean potential functions or original functions, and the lowercase q of t is a derivative of the capital Q. That gives the number of bacteria in the petri dish at any time t. How many bacteria are in the dish after 2 hours? Whoa, after 2 hours. All right, so first we want to find the potential function. Right, so we see capital letter T, Q of T. It says anti-differentiate 3 raised by T. When we anti-differentiate, which is 3 raised by T divided by ln, 3 raised by T divided by ln 3, right? ln of the base. Then plus C. Because when we take a derivative, right? When we take a derivative, what's the derivative of 3 raised by T? We will do 3 raised by T times ln 3. So anti-derivative is opposite. So we'll do divide. Then after 2, so at t equals 0, we have q of 0 equals to t equals 0. So we have 3. Why do we have 10? Q of t 3 raised by 0 ln. So that's 1 divided by ln 3 plus c. Okay, we're given 1,000 bacteria, but the unit is in thousands. That's why we have t there. Okay, so the unit Q of t is in thousands. So for 10,000 bacteria, we have 10 here. So at time 0, we have 10,000. That equals to 1 over ln 3 plus c. You see, we're given an initial point. So 0, 10 is an initial point for function capital letter Q. So when given initial point, we can solve for a specific c. So from here, we solve c equals to 10 minus 1 over ln 3, or 10 minus 1 over ln 3. All right, so that's about 9 something. Then we can write the function q of t. So a specific function of q of t. So a specific function of q of t is equal to 3 raised by t divided by ln 3 plus the constant c, plus a specific constant c. Anyone has any questions? Oh, okay, let's see this. Let me see. Oh, okay, why we have this 10 here? Okay, you see here, q of t, the units of lowercase letter q of t is in thousands. So q of t is measured in thousands. So here we're given at the time 0, we have 10,000 bacteria. That's where this 10 come from. So this 10 means 10,000. This 10 means 10,000. Does that make sense? Okay, all right, good. Okay, good. Now let's go back. So basically 0, 10 is given as an initial point, right? So with this initial point, we can solve for a specific c. Now we get a specific function, capital letter Q of t. Then after 2, right? So after 2, think about it. If we talk about, we can actually do this question in 2 ways. But anyhow, so after 2, if we can do this one, it's like, the lower limit is 2, the upper limit is infinity, right? But we'll find a potential function because we're given this initial point. At the time 0, have this 10,000 bacteria, so we can use this potential function. Once we use the potential function, we just find Q of 2, right? Just find a Q of 2. So Q of 2, just plug into the function, so we get about this much, 17 point something, which means 17,000, right? Because the function value is measured in thousands. So 17 point something means 17,282. All right, any questions for this? All right, so okay, let's see this one. Fruit fly population growth. Suppose a population of fruit flies increases at a rate of g of t equals to 2 times e raised by 0.02 t, exponential function a, in flies per day. If the initial population of fruit flies is 1,100 flies, how many flies are in the population after 10 days? You know, we would do something similar as the previous example. So we want to find the potential function. So we want to find the antiderivative of this lower letter g, and we call capital letter G, capital G of t. So we anti-differentiate. Oh, this one even did another way. Okay, this one did. Okay, I like this one. I like this way. This is saying, you know, what's G of 10? That's just the starting, right? The value at the starting point plus from 0 to 10. Right, so G of 0 is 100 is given, right? 100 flies in the beginning. Then from 0 to 10, we just anti-differentiate the lowercase g of t. Then after do that, we evaluate what anti-differentiate to get this 2 divided by 0.02 e to the power 0.02 t. Then we evaluate from 0 to 10. In the end, we get 100 plus 100 e raised by 0.2 minus 100. So we just get 100 e raised by 0.2. We can plug into a calculator, so we get about 122 flies after 10 days. Okay, anyone has any questions for this? All right, keep moving. Okay, let's see this one. Evaluating a definite integral uses substitution. So the integral is e raised by 1 over x. Right? So we want the u to be 1 over x. And then du dx will be negative 1 over x squared. And then we see x squared here, right? We just have to offset by negative sign. So we let u be 1 over x. That's x raised by negative 1. We take a derivative. We will get negative 1 over x squared. Right? That means 1 over x squared dx is negative du. So we substitute. So we substitute, we get e to the u, right? Negative du. So we have negative e to the u du. And then we can evaluate, we can change the limits. So u of when x equals to 1, u equals to 1 over 1, u is 1. When x equals to 2, we have 1 over 2, we get a half. Right? So u of 1 is 1, u of 2 is a half. And we have this negative sign. Remember the negative sign, we can switch limits, right? If we change the upper, if we switch lower limit and the upper limit, that introduce a negative sign. So here, negative become positive. Then we switch half and 1. Switch the lower limit and the upper limit. So we get e to the u. E to the u is e to the 1 over x. Oh, we don't have to do that anymore. We don't have to change it back anymore because we changed the limits. If we have changed the limits to be a value of u, so we don't need to substitute u back into x. So we just evaluate e to the 1, subtract e raised by half. So that's e minus square root of e. Any questions? right, keep going. Okay, you try this one. 1.37, everybody. Okay, especially for the rest of you. Sorry, can you repeat really quickly? Oh, sorry, which part do you want me to repeat? Let's go back. So the integrand is e raised by 1 over x divided by x squared, right? So e raised by, so we want u to be 1 over x, right? 1 over x, we can write as x raised by -1. Then du will be -1 by power rule, will be -1 times x raised by -1 minus 1, which is -2. So we'll have du equals minus 1 over x squared dx. You see that in the integrand we'll have 1 over x squared, right, dx. So 1 over x squared dx, that's a negative du. Then we substitute that. We substitute negative du and the u, so we'll have negative e to the u du. Does this make sense? So from here, so whether u, let u, so integrand will have e to the 1 over x. Okay, so either way, all right, thank you. All right, so make the sense, all right. Yeah, always ask questions. If you don't, I just assume everything's fine. All right, everybody, I do mean everybody do 1.37. I mean, for those of you who haven't shown me your answer yet, please show me you understand what I was talking about. Okay, I just got someone just came in. Let's see. Oh, Bishin. Okay, Bishin just came in, so I needed to take another picture. Bishin, we were talking about anti-differentiate the integrand with exponential functions. We still use U substitution. You're welcome. You're welcome. Let me know if anyone has any questions. So let's give a hint, especially for Bishin, you just came in. So you see the integrand with the e term. So let u be the exponent of the e term. Then figure out the du in terms of dx. Then substitute, the dx term into du. All right, try to use u substitution. So my hint is let u equals to the exponent of e, which is a 4x raised by -2, or equals to 4 divided by x squared, right? Whichever you feel more comfortable to write. Interesting. Okay, I got it. Show me your answers. Two. Let me see. Maybe I make a mistake. That's 1, 2. So u of 2 is 1, right? And the u of 1 is 4. Okay, got it right. Let's see. Negative 1/8 e plus, okay, Zenith, oh, okay, so you separate. So basically you have the same answer. So 1/a of e to the 4 minus e, right? Let's see, the carrier, yes. Okay, Darren, negative 1/8 times e minus e raised by 4, you can simplify, can be simplified, right? That's 1/8 e raised by 4 minus e. Okay. Ali, check your answer. Right, check your answer, Ali. Paul, yes, Paul, you would put the parentheses around e raised by 4, close at e raised by 1. Yeah, James, the same thing. Can be simplified, negative 1/8, right? The negative sign you can distribute inside. Okay, raw, if you want to write it this way, you need to put the parentheses around e raised by 4 minus e. Fujun, good, just like Fujun's. Yes, good. Raw, good. All right, okay, looks great. Thank you, guys. Anyone, no one has questions, right? Anyone has any question? All right, great. Okay, let's see this one quickly. Integration formulas involving logarithmic functions. So x raised by anti-differentiate x raised by -1, that's ln absolute value of x, right? Because the domain of x. So that's why we have to put the absolute value of x. Anti-differentiation ln x, that's x ln x minus x plus c. You know, I can never remember this. I have to use u substitution every time, or x times ln x minus 1 plus c. If you can remember, you know, it's faster. If we have log a, you know, if we have log base a x, that's just under differentiate, that's just x divided by ln a, then ln x minus 1 plus c. All right. Okay, I'm not expecting you remember the second one, third one, but at least remember the first one, okay? If we anti-differentiate 1 over x, that's ln absolute value of x plus c. Okay, at least I remember the first one. That's why I want you to remember the first one. The second one, third one, if you can remember, you know, perfect. If you're not, that's okay. Okay, let's see this one. We want to anti-differentiate 3 divided by x minus 10. So, right, rational functions, right? Especially, right, it's linear, it's rational, the denominator is linear. So it's a 3 raised by x minus 10. Right? So 3 we can factor outside. So we would have x minus 10 raised by -1. So anti-differentiate that, that's the ln absolute value of x minus 10 plus c. And here, right, because ln doesn't take a value 0, right? It has to be greater than 0. So the domain of ln is, you know, x has to be greater than 0. So that's why here, x minus 10, we have absolute value sign. So we force this one to not be negative, but we did not force this to be 0. So we have to put x not equals to 10. So I have put this extra condition. absolute value of x minus 10, then x cannot be 10 because 0 is not in the domain of Ln. All right, let's see more. Let's see this one. 1 over x plus 2. Well, under differentiate, so this is Ln absolute value of x plus 2, right? Then plus c. Ooh, let's see this one. So what do we have to do with this one? We have polynomial degree 3 as a numerator. We have polynomial degree 4 as denominator. So use substitution. So we let u be the denominator, x raised by 4 plus 3x squared. Okay. So then when we take a derivative of that u, we get a 4x cubed plus 6x. And that's so closely related with the numerator. It's just it's just double the numerator, right? It just doubles the numerator. The numerator is 2x cubed plus 3x. And du is 4x cubed plus 6x. So that means so du equals this. So that means half of du equals to our numerator in the integrand. Right? Half of du equals to this, equals the numerator in the integrand. So now we can substitute. So this is half of u raised by -1, or 1 over u. Well, 1 over u, that's Ln absolute value of u. We carry half. So u equals x raised by 4 plus 3x squared with absolute value sign. Okay, so anyone has any questions? So we have 1 over x, but this x has a derivative. So by chain rule, like a big X, right? So this big X is x raised by 4 plus 3x squared. Its derivative is 4x cubed plus 6x squared plus 6x, and which just doubles the numerator. It doubles the numerator. So 2x cubed plus 3x dx is half of du. So we get half of u raised by -1. So we get half of Ln and differentiate absolute value of u. So we get this. Anyone has any questions? All right, keep moving. Okay, now we have log base 2x. So we just follow the formula given, right? the second formula given. If this is in the test, so I can give you the formula. All right, I can give you the formula, so you don't. Yeah, I don't memorize it. I cannot memorize it, so I'm not requiring you to memorize it either. So by the formula, this is equals to x divided by Ln 2 times Ln x minus 1 plus c. All right. Okay, let's see this one. So the denominator is 1 plus cosine x. The numerator is sine x. We probably want u to be the denominator 1 plus cosine x. So when we take a derivative of that, we would get negative sine x. Bingo, that's in the numerator, right? So we let u be 1 plus cosine x. So the numerator is sine x, denominator is 1 plus cosine x. The limit goes from 0 to pi over 2. So let u be 1 plus cosine x, then du equals negative sine x dx. Bingo, we have sine x dx, right, as a numerator. We just don't have this minus sign. So that means sine x dx equals minus du. And we substitute. Well, we can change the limit. So u of 0, when x equals 0, u of 0 is 1 plus cosine 0, which is 1 plus 1, which is 2. U of pi over 2 is 1 plus cosine pi over 2. Cosine pi over 2 is 0, so it's u equals to 1. So we substitute u, we substitute the lower limit and upper limit. 0 now change to be u of 0, which is 2, And pi over 2 now it's need to be u of pi over 2, which is 1. And the integrand becomes negative u raised by negative 1. Now 1 over u, we can anti-differentiate, right? Just ln absolute value of u, then we evaluate it from 1 to 2. You see, if negative 2 to 1, then we switch the upper limit and lower limit, so that gives this negative sign, because negative become positive. So we just get ln 2 minus ln 1. Well, what's ln 1? ln 1 is 0, so we just get ln 2. Anyone has any questions? All right, keep moving. Oh, okay, let me see. So we're going to assign you some homework from here. So later on, we're going to learn something called partial integration by parts. So then we know we don't need to remember some formulas. So let's see, 320 we did already. Let's do 321. So this is your homework 3. 321 up to. Will you post the homework on my? Yeah, I will. I will do that. I will post on Blackboard and also on my Open Math, so you know exactly what to do. Okay, I will do that. So this is 1.6, 321 up to. You know what? I don't want you to do this now. 328. I don't want you to do it. So in the future, we're going to learn something called the, integration by parts. Okay, up to 327. So 321 up to 327 for this one. Now let's go to 1.7. Is this homework due next week? Yes, homework is 1 week apart. You are right. Okay, now is homework due next week. Inverse trigonometry functions. Is this in the syllabus? Let me check this quickly to see. Oh, I think this is in the syllabus. Yeah. All right, so 1.7, integration by, so inverse functions, inverse trig functions, okay, like arcsine, arccosine, arctangent. So we have to remember these formulas. Okay, let's see, 1, 2, 3. 1, 2. You know, I can remember the first two. I have trouble to remember the third one. Hopefully you can remember all of them. So let's go through this. So when the integrand is 1 over square root of a squared minus u squared, right? So look, the u is the variable, right? So that one we have arcsine u divided by absolute value of a plus c. So arcsine has this square root of a squared minus u squared. Actually, I hope this text shows us a picture. It's all about you making a triangle. Okay, you're making a triangle, you see that. And arctangent, the denominator is a squared plus u squared. All right, so 1 over a squared plus u squared. Arctangent, so we have 1 over a arctangent u divided by a. And arcsecant is kind of troublesome. It's a u, so the denominator is a u, square root of u squared minus a squared. So we can compare this one with the first one. The first one we have a squared minus u squared. And this one we have u squared minus a squared. And outside we have u. So anti-differentiate that, we have 1 over absolute value of A secant of absolute value of U divided by A plus C. Right? So this one, again, I don't remember, so I'm not requiring you to remember. You know, if it did happen in the test, so I'm going to give you the formula. But try to remember those two. Try to remember the first two. So arc sine, right, U divided by absolute value of A plus C. It has a form, and the integral has a form 1 over square root of A squared minus U squared. And arctangent has a form of 1 over A squared plus U squared. Will you provide review sheets for our exams? Homework, Fujun. Basically, it's homework, okay? If you do homework, if you try every homework, I'll pick and choose from the homework. Maybe I'll change a little bit, you know, little bit numbers. So homework is your review sheet. So I try to simplify this course. So exams are based on homework. You are exactly right. Okay, so we're not going to prove this, but let's see some examples. Let's see this example. So we're evaluating from 0 to half about 1 over square root of 1 minus x squared. So we have a squared minus u squared, right? Square root. We have a square root of a squared minus u squared. That's arc sine of u divided by, in our case, our a is just 1, right? So we'll just have arc sine u plus c. We just have arc sine of x plus c. Okay, Paul is saying, you mentioned you didn't like my open math pre-made questions. They don't have enough pre-made questions for me to choose from. Is it safe to assume that the test questions will be based on the textbook questions we're currently using for homework? You are exactly right, Paul. You are exactly right. Okay, let's show this. Right. So we just got arc sine x evaluating from 0 to half. Right? So arc sine half minus arc sine 0. What's arc sine half? Well, in this case, we could remember arc sine has a domain, right? So arc sine half is just pi over 6. Arc sine 0 is 0. So we just get pi over 6. If you forget about arc sine, the domain of arc sine, draw the picture for yourself. Okay. Okay, let's see this one. This one, a is 1. Well, u is not only x squared, right? So u is 4x, isn't it? U is 4x. So we would have arc sine 4x, right? Arc sine 4x plus c. So this one we do have u, right? We do have a. A is 2. So u is 3x. So u is 2. So we have 2 squared minus 3x parentheses squared. So 2 squared minus u squared. So 2 squared minus u squared. So in this case, all right, so let's start from beginning. So the book says, let u be 3x, then du equals 3 dx, right? So then dx equals 1/3 of du. So we substitute, so we have 1/3 of du, then divide square root of 4 minus u squared. And 4 minus u squared, 1/3 of this, 4 minus u squared is 2 squared minus u squared. So our a is 2. So get 1/3 of arc sine u divided by 2, right? Absolute value of 2 is still 2, plus c. So just have 1/3 of x sine 3x divided by 2 plus c, right? 3x. So we just let u be 3x. Because why we use 3x? Because 9x squared is parentheses 3x squared. So that's our u. Any questions? All right, let's keep moving. Okay, let's see this one. This one we have 3 squared minus u squared, right? 3 squared minus u squared. So we would have x sine x divided by 3 plus c. Right? Just follow the formula. Let's see this one. This is definitely integral, right? We want to evaluate from 0 to square root 3 over 2. And the inside we did get 1 minus u squared. Oh, that should be easy. Just have x and u. We want to evaluate from 0 to square root 3 over 2. Well, what's x sine square root of 3 over 2? That's pi over 3. What's x sine 0? That's 0. We just get pi over 3. Okay, arctangent. Let's see. Here we have 1 over 1 plus parentheses 2x squared. So a is 1, u is 2x. So we let u be 2x. So we let u be 2x. Then du equals 2 dx, or dx equals to the half of du. So we substitute, we get a half of 1 over 1 plus u squared du. Then we know 1 over 1 plus u squared, anti-differentiate, we get arctangent of u divided by a says 1. So arctangent of u plus c. So half of arctangent, 2x plus c. All right, so let's see this one. This one, our a is 5, right? Our u is 2x. Again, we'll let u be 2x. So du equals to 2 dx, right? Very similar. So I'm not going to ask you to do this. Let's do this one first, quickly. So I have 9 plus x squared. So we have 3. So our a is 3. Our u is x. Right? That's just 1/3. Because a equals 3, that's just 1/3. Remember, that's 1 over a. Arctangent x divided by 8. Absolute value of 8. Well, here it's just positive, just 3. Just by the formula. All right. So here a equals 4, right? U is just x. So let's see this one. We have 1 plus x squared. Evaluate from square root 3 over 3 to square root 3. So we get arctangent of x. We want to evaluate from this square root 3 over 3 to 3. Well, what's the arctangent of square root of 3? What's arctangent of square root 3 divided by 3? I actually don't remember. Anyone remember arctangent square root 3? So which means the tangent what angle equals to square root 3? I don't remember. Good job, you guys remember. You think 60 pi over 6? Pi over 6. Let me check. Pi over 3. Pi over 3 is 60, right? So arctangent square root of 3. It tells me in radian. Okay. In radian. Anyway, good thing is I don't ever have to take tests anymore. I don't remember this. Anyway, you check, okay? So arctangent square root 3, arctangent square root 3 over 3. All right, so yeah, I think we have a little time. So, okay, try this then. Try from 0 to 2. 1.44. Everyone try 1.44. So I'm going to try myself. I'm going to also see if I can get. So I get to use half of arctangent. Yeah, this is arctangent of 2. Huh, do we have an arctangent 2? Arctangent of 0. Let me see. Everything is good in reading. Why is it in reading? I can use what's the code? Oh my goodness, website code. Oh, what's the website? What's the website? Oh, let's use the decimals. Arctangent. Interesting. They all give me radian. They don't give me degree form. All right. Arctangent. Okay, I guess I need to study the angles. You know, ideally, we remember, you know, pi over something, pi over 3, pi over. Well, you don't have to give me exact values, right? You just give me arctangent of something, minus arctangent of something, all right? Half of arctangent 1.
I just showed the step. That's what I'm trying to show.
Oh, okay. So pi over 8, huh? Okay.
Yeah, I know how to like input the boundary, but the boundary on top is 1 and the lower one 2, so I couldn't show like that. But it's like half. Okay, you guys are trying to say, right?
Right. So, but my answer is a little bit different from you. My answer is 1.1 something. Is I wasn't able to get a pi over 8. So arctangent divided by 2. Oh, you're right. Arctangent 1, arctangent 0. Right. What about the rest of you? Did you all get a pi over 8? Right. If we remember it, we could get the exact value.
Do we get participation for point?
I'm sorry?
Do we get participation point?
Yeah, ideally, I want to give to everybody. You know, so far, if you have, you know, present yourself in the class, I have given you full credits for that. But ideally, everybody can participate, you know. Oh, I think I have one more person because I have 20 people now. Someone just came in because I don't want to miss anyone. Oh, Jack just came in. Okay. All right, Jack, you missed the first part. We were talking about exponential functions. You can go back to watch the recordings, all right? Because I always record the class. Okay, when we're gonna go over this one, let's go over this one. Okay. Okay, let's go over this one. So this will have 4 plus x squared. Let's go to the whiteboard. From 0 to 2. So lower limit 0, upper limit 2. We have a dx over, you know, dx in the numerator is same as dx on the side, right? They're all numerators. So 4 plus x squared. Okay. So let's figure out, in the formula, we have a, we have u, right? So we figure out a here, a squared is 4. That means a equals to 2. U equals to x, right? So we figure out here. So let me show you one more time about the formula. So basically, let's try to remember only 2 formulas. Okay, the first 2. Okay, the first one is the square root of a squared minus u squared in the denominator. Right? And then that's arcsine of u divided by absolute value of a. So we did a couple of exercises. And the second one is arctangent. Arctangent, we have to have the integrand as 1 over a squared plus u squared. So here we have 4 plus x squared. So our a is, because 4 is 2 squared, so our a is 2. Right? Our a is 2. And our u is x. So following this, so we'll get a half of arctangent of u, which is x, divided by 2, plus c. Right? By the second formula. So now let's go back to whiteboard. So that means, so this equals, equals to, well, this, so 4 is 2 squared, right? So that means a equals 2. So by the formula, we just have a half of arctangent of x divided by 2 plus c. Right, plus c. But here we're dealing with a definite integral, so we don't need plus c. We just want to evaluate from 0 to 2. So we have a half. So difficult to write here. So let me type. I have a half of arctangent, right? And 2 divided by 2, we evaluate 2 divided by 2, that's 1. Arctangent 1 minus arctangent. Actually, I can write this way, arctangent of 0. Okay. Well, arctangent 1 is easy, right? I remember arctangent 1. So we get a half of pi over 4. Subtract. What's arctangent 0? 0, right? Right? Just 0. So we don't really have to write it. Just pi over 8. Okay, so anyone has any questions? Okay. Have we gone this far yet? Yes. Oh, you're welcome. You're welcome. Questions are always good. Make sure. So ideally for those problems, all we have to do is memorize the formulas. Yes, for those two formulas, because you know in the future it'll be very often used, so you know we should remember them. But you know what, you don't really have to, right? So for the exams, if you don't remember, I'll remind you. But if you have to remember, the first two you have to remember. The first two, I think, it will appear in the exam. Because it's arctangent and arcsine, it's very often used, so you have to remember. I won't be able to give you formula for that. Okay, try to remember those two formulas. All right, so now let's go back to the book. Okay, now let's see. So part of homework 2 is homework 3 is also 1.7. Let's see. So that's good. That's good. So 391 up to, you know, when I was a student, right, I almost finished every question, you know, from the exercise. Not this book. This is from Stewart's. It's in Stewart's Essential Calculus. It's like a classic ones. So up to 1394. But I understand nowadays you guys don't really have that kind of luxury time. When I was young, I had plenty of time. So 397 up to 400. Maybe just one exercise, 401. All right. So use calculator graph. Oh, this is use calculator graphing. I don't need to graph it, but oh, those are Q functions. Q ones. Let's see, 411. Okay, let's see. So 423 up to, okay, 423, 424. This kind of questions is testing you about, you know, your trigonometry functions skills. They don't give me the other kind I was looking for. Okay, all right. So I'll show you which one to do later. So we have some time. Let's go to area between curves 2.1. So far we are able to find an area for a irregular shape with one side being irregular. Now what about if we have an irregular shape, right? Think about this shape, irregular object. No, that object with two sides being irregular, with the two sides are not straight. So just like this shaded one, right? Think about this shaded one is some object. And we want to find the area of this. So what do? So we're going to put it on the coordinate plane and think the lower part is a function, the upper part is a function, right? Leave the other two straight sides. That's just our interval. And we want to find the area in between those two functions. Upper minus lower, you're exactly right. Exactly right. Since we know how to find area under the curve, right? So this is just, you know, two areas and two areas under two different curves, and the middle part just overlap. So we use the area under the upper function, subtract the area of, you know, over the lower function. So that's it. That's it. So it's just the area of this, right? Subtract the area of this. Then we get the area of this irregular shape. So that's the idea. Right. So once we understand that, the rest is just easy, since we know how to find the area under this, right? So for this typical one, we want to find the area under the curve G, and the area under the curve F. So we do F minus G. So we integrate F minus G. That's it. That's all it is. Well, the idea exactly the same as before, right? So the infinite integral comes from taking limit of cutting infinite pieces, right? So the idea is the same, right? So the integrand is f minus g. The upper one subtract the lower one, of course, from the interval, right? So we have lower limit, upper limit. Let's see this one. Finding the area and the region between two curves. So we have f of x equals x plus 4, or linear, right? A straight line. And the second one is 3 minus x over 2, linear straight line. In between of 1 minus 4. We could just draw these two, right? If we draw these two, let's see if I have a picture. Oh, we do have these pictures. These pictures. I should do this upgrade. I should do later. Okay. So we draw f of x equals x plus 4. We get this blue line. We draw the other one, g of x equals 3 minus x over 2. We get the down lines. So from 1 to 4, right? From 1 to 4, we just do f minus g. So the integrand is f minus g. So f minus g, x plus 4 minus 3 minus x over 2. So just get a new function, 3x over 2 plus 1. Then we integrate this and differentiate this, evaluate from 1 to 4. We get 57 over 4. That's it. And we don't care about the units, right? We don't care about the units. Just a pure mathematical idea at this moment. So 57 over 4. Let's see this one. Sometimes what's the difficulty is sometimes, you know, we need to draw the picture right. We need to draw the graph function right. That's one of the challenges. So let's see this. If R is the region bounded by the graphs of the function f, it's a linear function. G is a linear function. Over the interval 1 to 5, find the area. Same thing, same exact thing, right? So we need to draw a linear function. So get 2 points, get x-intercept, get y-intercept. With 2 points, we can draw the line. Finding the area of the region between two curves. If R is the region bounded above by the graph of the function f of x equals 9 minus x over 2 squared. Well, quadratic function, right? Quadratic downward parabola. So because the leading coefficient is negative quarter, so negative quarter is negative, so get downward parabola. Below by the graph of the function g of x equals 6 minus x, a line, a straight line. Find the area of the region R. Let's see. So we have to draw the graph, right? Well, we don't really have to draw the graph, right? But just the graph is help us to visualize. Because sometimes if we get negative area, we just flip f and g. All right. So if we draw the graph, we see f is above g here, right? F is above g in the interval from what? Oh, it didn't see it. Okay, this one you see. Okay, so this one we're not given from what interval. So this is bounded by, okay, the region is bounded by those two graphs, those two functions. So that means we have to find our lower limit and upper limit. How do we find the lower limit and upper limit? If the two graphs intersect, right, they have to have the same point. So we just equal those two functions. When the two functions are equal, right, they intersect. So we set those functions equal, we solve for x. right? Set them equal to each other, solve x. So I have a quadratic function to solve. So this is, we simplify, so we say, okay, this is factorable. And then we get x equals to -2 and 6. So we get x equals -2 and 6. So we get the lower limit is -2, the upper limit is 6. Okay, we want to find the area is bounded by those two graphs. That means the inside is bounded by those two graphs, right? And f is on top, and this g on the bottom. We just do f minus g as the integrand. Lower limit is -2, upper limit is 6. So lower limit is -2, upper limit is 6. Just do f minus g because f is above g. So after we simplify the integrand, we get a quadratic function. We anti-differentiate, we get a cubic function. We evaluate at -2 and 6. In the end, we get 64 divided by 3. All right, anyone has any questions? Pretty simple, right? All right. So just one more thing for here to do, right? So sometimes we don't really have to draw the picture, right? Sometimes we don't really have to draw the picture. We can, even if we're not given the intervals with a set of functions equal to each other, solve for x, we get lower limit, upper limit, and maybe we just don't know which function is above which, right? Which one is above, which one is down. But when we do the calculation, if we get a negative answer in the end, so we know we just switch the integrand. We just switch f and g, right? If we do f minus g, we get, in this case, if we do g minus f, if I don't want to draw the picture, if I'm not asked to draw the picture, to sketch the picture, so I don't really have to draw the picture. So draw the graph, I just do f minus g. If in the end I get negative value, I just switch g and f, right? In this case, if I do g minus f, I will in the end get -64/3. So, to offset negative sign, I just switch f and g. All right, let's see more. Areas of compound region. Yeah, that's what I was talking about, right? Basically, the absolute value of the integrand. If we don't want to, if we don't have to draw the graph of it. Let's see this one. If R is a region between the graphs of the function sine x and cosine x over the interval 0 and pi, find the area of the region. From 0 to pi, we know what happens, right? They will offset some area above. Let's see this one. Oh, over sine and cosine. So we draw the two graphs, sine and cosine. We can see here. So we have sine graph, right? We have the blue one is cosine graph. Cosine and cosine just off by pi over 2, right? They're exactly the same, but just off by pi over 2 units. So we see from 0 to pi, the region is just bounded by those two, which is this one and this one. So let's see. So we need to find the absolute value of it. Why is that? Oh, because you see here, down here, we have some areas down below x-axis. Below x-axis. Let's see. So this thing, okay, in the interval 0 to pi over 4, cosine x is greater than sine x. Yes, right, from 0 to pi over not pi over 4. From 0 to pi over 4, we see cosine is above sine. But then from pi over 4 to pi, sine is above cosine. So that's why we're putting absolute value signs there. So from 0 to pi, we're going to split into 2, from 0 to pi over 4, and then from pi over 4 to pi. So in this case, we have to draw the graph to be able to see this, right? Yeah. So in 0 to pi over 4, cosine x is above sine, so we do cosine x minus sine. From pi over 4 to pi, we do sine x minus cosine x. Then we anti-differentiate, we evaluate. In the end, we get 2 square root of 2 unit squares. Okay, anyone has any questions? Oh, it's time. I'm sorry. I went over time. So this is just a little bit ahead, all right? So I'm not going to assign you homework on this. So homework I'm going to post on my open math and also on Blackboard, all right? Anyone has any questions? Yeah, always upper minus lower. But if sometimes we don't want to draw the graph, or we don't have to draw the graph, you know, if we get a negative value in the end, we just switch the integrand. We just switch f and fg. Yeah, for mathematics, I don't know why they don't want you to, they want you to be able to come up with a graph of a function. I think that's why. That's why they don't want you to use graphic calculators. All right, any other questions? All right, have a good night then. See you on Thursday, all right? Good night. I'll post the homework on my open math and Blackboard. Okay, good night. Let me stop recording.